The M20 uses the motor as a sensor and a unique algorithm to calculate the output shaft power. This patented feature of the M20 makes it the most advanced motor load monitor available and allows us to reliably protect the driven equipment against abnormal overload or underload conditions. More than 500,000 M20 load monitors are being used throughout the world to protect motor-driven equipment and to help maintain production uptime. The M20 is an electronic monitor that typically resides next to its motor starter. No mechanical elements are required to be installed on the motor or on the driven equipment. Installation is both simple and quick, typically taking a qualified electrician just 20 to 30 minutes to install. Here we have an M20 installed into a small NEMA 4X enclosure, and although this is being shown in this configuration for demo purposes, the same enclosure can also be utilized when the existing motor control panel has insufficient room to accommodate the unit. This particular unit is installed to protect a magnetically driven centrifugal pump. Dry running or deadheading this type of pump will typically result in catastrophic damage within a very short time period. The manufacturers of these particular types of pump consider it essential that they be protected. This graph demonstrates the fundamental differences between the abilities of a current monitoring situation and that of the M20 shaft power monitor. This graph shows motor current and power on the vertical axis and motor load on the horizontal axis. The red line shows what happens to the current as load increases. Note how it remains virtually unchanged until the motor load reaches approximately 60 to 70% of the motor's related power. The blue line shows motor power, or in this case, the motor's calculated shaft power. As you can see, it is linear from zero load to full load. This makes it much easier to detect abnormal load conditions, especially those associated with underload. This meter will display the motor current, whereas this meter will display the motor shaft power. Here we witness the M20 being used to protect the pump against a variety of typical abnormal situations. But first of all, let's go ahead and start the pump. The M20 is displaying the motor's load as a percentage of its related power. It can also be set to display horsepower, kilowatts, or percentage kilowatts. Next we will teach the M20 what the normal load is, and at the same time establish 4 levels of protection, 2 for overload and 2 for underload. All of this is achieved by simply pressing the auto set button for 3 seconds, a unique and patented feature only found on the M20 load monitor. At the end of the 3 seconds, the word set appears on the window of the M20. As we can see here, the pump is taking approximately 64% of the motor's related power to operate under normal conditions. Next we will go ahead and start to dry run the pump by slowly closing off the suction valve. As we do this, we see our load drops, and when the valve is about halfway closed, we can hear the pump start to cavitate, and at the same time, we see the M20's first alarm point activate. This is called the pre-alarm, and in this example, we are simply using it to illuminate a warning lamp. If we now continue to close down the suction valve, the M20's main alarm will now activate and the pump will be shut down. In circumstances where it may be undesirable to shut the pump down, the M20's alarm relay could simply be used to send a signal to warn off the problem. The M20 will now visually signal an alarm condition by bringing up the fault underload message in its display. We will now go ahead and reset the alarm by pressing the remote reset push button, and then restart the pump. Next we will demonstrate the M20's ability to detect a deadhead condition. To do this, we will close back the discharge valve. Again, we will see that when the valve is about halfway closed, the M20's pre-alarm relay will activate and the alarm lamp will illuminate. As we continue to close back on the discharge valve, the shaft power will drop quite dramatically. Note once again how the current meter is barely moving. At the point where the valve is fully closed, the M20 will once again shut down the pump. Next, we will demonstrate how the M20 will shut the pump down if it is started in an abnormal condition. In this example, we will start the pump with a closed discharge valve. After just a few seconds, the pump is shut down and an alarm message displayed. We will now demonstrate the effects of air being entrained into the pump. First, we will show a relatively small burst of air being let into the suction side of the pump. This may be consistent with a small system upset and one that you wouldn't want the pump to be shut down on. Note how the load meter changes significantly, but that it recovers before the M20's alarm response delay has expired. In this installation, the delay has been set to 4 seconds, however, it is adjustable from 0.1 seconds to 90 seconds. We will now entrain much more air into the pump, maybe consistent with, say, emptying a tank. After the alarm response delay has expired, the pump is shut down. We will now take a look at the M20 being used to protect a progressive cavity pump. Here we see the M20 installed in a motor control panel. The M20 and its associated current transducer are typically located close to the motor starter. As with the demonstration of the centrifugal pump, we were able to set the M20's 4 levels of protection by simply running the pump under normal conditions and then pressing the auto set button for just 3 seconds. If we now go ahead and close the discharge valve on the pump, the M20 will monitor a rapid increase in shaft power. Failure to shut this pump down under these conditions will almost certainly result in significant damage to either the pump and/or its system piping or controls. The M20's fast response delay of 0.1 seconds is fast enough to protect against this condition. What we will now demonstrate is the M20's ability to protect against the dry run condition on this type of pump. If we go ahead and close off the suction valve, we will see that the M20 shuts the pump down and signals an alarm condition, both via an external lamp as well as via the fault underload message on the display of the M20. No matter what type of motor-driven pump you may have, one thing is for sure: unforeseen problems will occur. The M20 is designed to passively sit in the background, waiting for these events, and to provide you with the knowledge that expensive equipment damage and production downtime will be prevented.